This is the second part of Chapter 3.1. We'll be looking at weighted data and grouped data. We'll also be looking at the mean and the mode for those. First things we're going to look at is something called the modal class and the mode for grouped data. You've already dealt with the mode, which is the one that appears most often, but you have not found it for grouped data. So when we're dealing with grouped data, remember that's like a frequency distribution where you have class limits like between 1 and 5, 6 and 10. There are something called the modal class, which is pretty easy to find. You just find which class has the highest frequency, and that entire class is called the modal class. The mode for grouped data would be the midpoint of the modal class. Obviously, if the modal class has appeared the most, and we need just one number from that range of numbers, we just take the midpoint. For example, this is on page 111. Here is a frequency distribution for 20 runners that ran last week, and or ran in 1 week. We kept track of how many miles they ran. If we were looking for the modal class, we would be looking for the 5 right there, because that is the highest of all the frequencies. So therefore, your modal class is 20.5 to 25.5. You use this entire limit. This right now is a limit. It's not the boundaries. So this entire class limit is called your modal class. The mode would then be the midpoint of the upper and lower limits. So you just take 20.5 plus 25.5 and you get 46. Divide by 2, and that would give you a mode of 23. Mid-range we looked at yesterday, so I'm going to skip through that. Now we're going to look at weighted mean. Basically finding the average of weighted data. What we mean by weighted data is where the data, each value doesn't have the same importance or the same, we can look at it as different people having a different amount of votes, so they have more power, so that's weighted. It could be percentages. It could be a number of different things, but it's where the values are not all equal. When you're finding the weighted mean, you want to multiply each value by its corresponding weight. And like I said, those weights could be different things. They could be a percentage, they could be a number of votes, they could be, it doesn't always have to be a whole number, doesn't always have to be a decimal. Okay. Then you divide that, or after you multiply all of them, you add them all up and divide it by the sum of the weights. So here's what it looks like. So we've got our x bar, which is our mean, and you'll take whatever your first value is, that's x sub 1, and multiply it by whatever its weight is, or frequency. You will do that then for x2, the second value, times its weight, and you will do that for all the values, and then you will add them up. And that's why we have sigma of wx. This means add up all of the w's times the x's. And this down here is all of the weights added up. So this is sigma w, this is all the w's added together. Don't forget what that sigma means. So here we go. When you're in high school, calculating your GPA is fairly easy, and that's because every class counts the same. So a semester of gym class counts the same as a semester of art class, counts the same as a semester of math class, which we all know is way more important, and depending on your teacher. Spanish class should be worth about 10% because Solom Sauce teaches it, but that's a whole other subject. In high school, all your classes have the same weight. When you get to college, that's very different. The weights go off of how many credits each class is worth. It all depends on the class. Usually the number of credits goes along with the number of times you meet each week, but every university is different. So here we go. We have somebody's schedule for one semester. They have English composition, psychology, biology, and Phy-Ed. English composition is a three credit class. Psychology is a 3-credit class. Biology is a 4-credit. That happens a lot because sometimes science classes have a lab with them. Sometimes they're considered separate classes as well. And then you have a Phy-Ed, which is 2 credits. Here are the grades that the student received for them. An A for English Comp, a C for Psych, a B for Biology, and a D in PE. These are considered your points. These are your X values, and these are your weights. And that's because biology is weighed a little bit higher because you meet more often, or whatever the reason. It's worth 4 credits and therefore carries a weight of 4. So when we're calculating this, remember, we're going to take all of our weights times each value, add them all up. So we're taking our 3 times 4, 3 times 2, 4 times 3, and 2 times 1. We're doing that right down here. And then we're going to add all of them together, and you get the number 32. Then what we want to figure out is, well, how many credits do we have? 3, 3, 4, and 2 is 12. So these are the amount of points that you earned, or the student earned. These are the number of credits they took. Divide the 2, and that is the student's GPA. You can also find this when you're working with grouped data. Now, when you're working with grouped data, we have these limits. Now, the frequency, that's fairly obvious that that is our weight. But what's our X? Do we use the number 1, 2, 3, 4, 5? Which number do we use? What they want us to use for our X's are the midpoints. So to find the midpoint, you're going to take your lower limit, 1, plus your upper limit of 5. Not sure why this isn't working. And you get 3. And then you want to do the same for each one. 6 plus 10, 16, divided by 2, 8. 11 plus 15 is 26, divided by 2 is 13. 16 plus 20 is 36, divided by 2, 18. 21 and 25 is 46, divided by 2 is 23. 26 and 30 is 56, divided by 2 is 28. So now we have our X values. And so when we go to calculate this, we're asked for the mean. We would have our sigma of our X's times our W's divided by sigma of our W's. So here we go. We take 5 times 3, 7 times 8, 18 times 13, 6 times 18, 11 times 23, and 3 times 28. We're going to divide all of that, that's a bad line, by all of our weights added up. 5, 7, 18, 6, 11, and 3. I'm going to calculate these real quick. You double check my math. I got 750 for the top number. Oops. And $50 for a bottom. So that means that our mean would be 750 divided by 50, which gives us 15. So that is the mean, or the average, of this. Now, we can't say with 100% certainty that this is the average because we don't see all the raw data. Who knows? Maybe all five of these numbers, they were all ones. Or maybe they were all fives. That would have a very big difference, or a drastic difference on our mean. So without the raw data, we're not guaranteeing that this is 100% perfect average, but it's as close as we can get to an estimate of this without actually having the raw values. Okay. Now we're going to look at some of the good things, some of the bad things, just some of the properties in general of our central tendencies. So the mean, just like the mode and median, uses all the data, which is a good thing. It does vary less than the median and the mode, not meaning that it can't be changed drastically. It's just usually considered a more accurate measurement of the middle, or of the average of the data. Okay. It's used in computing other statistics, which we'll do later on in the semester. Later on in this chapter. And it's unique. It's not always one of your data values, which isn't a bad thing. I think it's actually a good thing. It doesn't actually have to be one of the values. It could fall somewhere in between. The bad thing about it is it cannot be used with open-ended classes, meaning if you were taking age groups and you were saying anyone aged 0 to 5, 6 to 10, and you go all the way up, and then you just say 85 plus, so meaning 85 and older. You can't do the mean with that. It is affected by extremely high values or extremely low. So one extremely high could really bump the average up pretty quick. Those numbers, when they're extremely high, extremely low, we call those outliers. With the median, this gives you the midpoint. This is nice when you want to find out, do you fall in the upper half, lower half. It can also be used for open-ended distribution, which is a nice thing. It is affected a little bit less by those outliers, and that's just because you're not. It's by the way it's calculated. You know, with average or with the mean, if you add something that is 3 times higher than the previous high number, that'll affect your average quite a bit. If you do that with the median, all it does is kind of move your median over a little bit. It doesn't affect it quite as much. Mode, this is if you ever want to know like what happened most often. It's by far the easiest. We can use it with nominal data, which means we can use it with like eye color and gender and characteristics, things of that nature. It's not always unique, which you could think of as a good thing or a bad thing. Sometimes you can have multiple modes. Sometimes you don't have a mode at all. Mid-range, very easy to compute, gives the midpoint obviously. This one, as well as the mean, is affected by outliers. Let me go back to that. And then lastly, distribution of data. They can be skewed to the right, skewed to the left, or not skewed at all. The way that we look at this is your mean is your middle. So when most of the data falls lower to the left side of it, it leaves a tail to the right. And that tail is what gives it its right skewedness, or positively skewed, but they usually call it right or left. When most of the data falls to the right of the mean, it leaves a tail on the left. That is why this is called left skewed. I don't know where that went. this is called left skewed or negatively skewed. And when your data falls pretty much even on both sides, we say that it doesn't have skewed, or it's symmetric. Okay, so we call this a symmetric skew. All right, that's all I got for you. We will see you in class tomorrow. Have a good rest.